So the lab that I'm covering here, I have 3 pictures of data. This is estimating the size of a mole lab. Now, there are 3 pieces of data you needed to collect in lab. The first one, you had to collect an empty graduated cylinder, the mass of it. You got a mass down here. I'll let you write that down on the paper. I'll also pull that up in a second. Then you counted out 25 beans. Well, they're really corn kernels. You count out 25 of them, put them in the graduated cylinder, weight it again. So to get the mass of the 25 that are in there, you're going to take this, subtract out the mass of the graduated cylinder. Then the graduated cylinder was filled to 75 milliliters with the beans. Then it was weighed again. To get the mass of the 75 milliliters, you take this mass, you subtract out the graduated cylinder from the beginning. So now I'll pull up the Word document. I already have a fair amount written down here. I'll get back to the pre-lab questions in a second. So here are the 3 data points that I just had pictures of. So you can copy this down if you're at home, copy this data. If you're in class, then you'll obviously use your own data. So at this point, if you're in class, this is where you can jump back in. And if you're at home, you can continue on with us. So the first thing here, we're going to do the pre-lab questions. Now in class I talked about Avogadro's number. I talked about what a mole is. I would recommend watching the What is a Mole video before doing this lab, whether you were in class or not. But a mole is equal to 6.02 times 10 to the 23rd. It's just like a dozen, whereas a dozen equals 12. A mole equals this number. So think of it as a counting number. We count things in that amount. Now for pre-lab 2, I'm going to give you these answers, or at least the first 2. To figure out how much 1 mole of gold weighs, you actually look up on the periodic table. It's the average atomic mass. In gold's average atomic mass is 196.97 grams per mole. When it's a single element, it's super easy. You just look it up. For aluminum chloride, it's a little bit trickier. You have to count, okay, there's 1 aluminum in the formula and 3 chlorines. So now I look up aluminum. Aluminum's mass is 26.982 and chlorine is 35.453. Now I multiply, because there's 1 aluminum, I multiply 1 times its mass. I can do that in my head. Now the 3 times chlorine, because there's 3 chlorines, I got to take the mass of 1 chlorine, multiply it by 3, and I get 106.359. Now what I'm going to do is I'm going to add these together to get the total mass of aluminum chloride. And the units for this is grams per mole. We'll actually talk about molar mass in like a day. For now, all I want you to do is copy what I just did and then repeat it for carbon, for sugar. So there's 6 carbons, there's 12 hydrogens, and there's 6 oxygens. So I want you to look up the mass of each. You calculate it out, and then you add it up, get the final answer down here. For pre-lab question number 3 now, what you do is you take the, let's see here, there we go, it's working. You take the number given, 24.65 grams of aluminum chloride. You bring grams of aluminum chloride down, and then you go to moles, because it's asking for how many moles would that be. So you put moles on top. Now, how many grams are in 1 mole? And we actually just figured that out. You'd put that number in, and then you take 24.65 divided by 133.341. So I'll let you type that in, write that in, save some time. For 4, you take the number given, you put it here. And again, if you don't quite understand this, just write it down, get it down for now, and it'll stick later, hopefully. This is just exposing you to it at first. It says how many moles. Now, how many atoms are in 1 mole is the question, and the answer to that is always 6.02 times 10 to the 23rd. There's always this many of anything in a mole, whether it's atoms, molecules, anything you want to talk about. There's 6.02 times 10 to the 23rd things in 1 mole. So divide these two, this first number, divide by 6.02 times 10 to the 23rd, write your answer will be in moles. Now for the calculations, let's actually get back to the lab here. You got your 3 data points if you're at home. You got your own if you were here. I'm going to, instead of walking you through this, I have things pre-written, so instead of writing it out, hopefully save some time. Like I said at the beginning, you have to subtract out the mass of the graduated cylinder to get the mass of 25 beans. The same thing is true for number 3. You take the mass with 75 milliliters of beans, subtract out the mass of the graduated cylinder. Now to calculate the mass of 1 bean, you take your mass of 25 beans, which is actually your answer from number 1. So your answer from number 1 divided by 20. Now for number 4, I have the hints here. You take your answer from number 3 divided by your answer from number 2. So the blue is a description. 3 tells you which where you get the numbers from. So for number 4, you take your answer from number 3 divided by your answer from number 2. And I can't give you specific numbers because each of you will have different numbers. For number 5, you take 75 divided by the number of beans that were in 75 milliliters, which is your answer to number 4. For number 6, you take the mass of 1 bean times 6.02 times 10 to the 23rd. Now my explanation for this one, if I asked you what is the mass of a dozen beans, let's say I said what's the mass of a dozen beans? Well, you'd be like, okay, you take the mass of one bean, multiply it by 12 because there's 12 in a dozen. The same logic holds true for moles. You take the mass of 1 bean. Well, if I want to know what the mass of 1 mole is, well, I just multiply it by however many things are in a mole. So mass of 1 mole of bean, answer from number 2, multiply it by this number. Same thing, similar to number 7 is similar to number 6. Okay, now let's go down to the conclusion. Pause that, go back and finish your calculations. I will let you do numbers 1 and 2 on your own. Number 3, why is Avogadro's number useful when dealing with atoms? I talked about it in some of my classes, some of them I didn't get to. But why do we count anything in groups? Why do we use dozens? We tend to count small things in groups because it's easier. So why is it useful when dealing with atoms? Well, atoms are so small, it's useful to count them in groups. The group we choose is the mole. That 6.02 times 10 to the 23rd. Just like we sell eggs by the dozen, we count atoms by the mole. Same concept, just a bigger number because atoms are small. Okay, numbers 4, 5, and 6. I'm going to walk you through these. You just copy this down, and I'll explain it. Listen as I go here. So it says, how many beans, use your calculation, calculate how many beans would be in 2 kilograms of beans. Now you could just take 2 kilograms, convert it to grams, and use your mass of 1 bean, but it says using your mass of 1 mole of beans. So we'll follow the directions. So we take 2.0 kilograms. We write our ladder. We bring kilograms down. We want to go to grams first because our molar mass is in grams. Now prefix gets the 1, kilo equals 1,000. Now I bring grams down and I go to moles. And this is very similar to the step we'll do in the next couple days. The mole always gets the 1. How many grams are in 1 mole of beans? Well, that depends on your answer. So that is your answer to number 6. So your number 6 is the molar mass of your beans. How many grams are 1 mole of beans worth? So you put your answer in number 6. Now what you do is you take 2 kilograms times 1,000, and then you're going to divide by that answer. That will be your answer in moles. Or sorry, I did. Give me a second here. Kilograms to grams. Calculate how many beans would be in 2 kilograms. Hold on, I'm going to pause. I messed something up here. I'm going to fix it. Okay, I had a little bit of a brain fart, so I just had to stop and think before I continued on. So I was just one step short. So this gets us from kilograms to grams. Then we get from grams to moles. Now we can convert from moles to beans. Now how many beans are in 1 mole? Well, there's this many of anything in 1 mole. So you're going to take this number times 1,000 divided by your answer number 6, multiply it by Avogadro's number. that'll get your answer in beans. Sorry about that mistake. Now, number 5, calculate how many beans would be in 0.25 moles. Well, this one's actually real easy. You just take 0.25 moles, bring moles down, go to beans, and you say how many beans are in 1 mole. It's just like the last step of the previous problem. There's this many of anything in a mole. So moles cancels out, and you're left with beans for your units. You multiply, you get your answer. It's in beans. Now the last one, number 6. If you had 1 million beans, let's write that out. Bring beans down. So it says how many moles would that be? So we're going from beans to moles this time. Here we went from moles to beans. Now we're going from beans to moles. Now the mole always gets the 1, and there is this many beans in 1 mole. So you divide 1 million divided by Avogadro's number. Now you might be thinking, oh man, 1 million beans sure is a lot of beans. And you're going to be surprised that you're going to get a super small number. You're going to get like times 10 to like, I think it's like the minus 18 if I remember right. Some numbers, so you got to calculate that out. Because even the number 1 million, as big as we think it is tiny compared to this. It is a small fraction of a mole. So you're going to get a really small number, so don't be surprised by that. Same thing here. 1/4 of a big number is still going to be a very big number. So you'll still get a very big number. So don't forget, your calculator will probably say E22 or E21. Don't forget to put times 10 to the 21 or 22, whatever your calculator gives you. So that'll conclude this lab. Finish this. This will be due next class when I see you.